We're going to determine if the series, the summation from 1 to infinity of the square root of 4n cubed plus 9n squared plus 1 divided by n to the fifth plus 16n squared plus 4 converges or diverges. And we're going to use the limit comparison test, and that's abbreviated LCT. Now let's quickly review how it works. Suppose we have two series, one denoted by summation of a sub n and the other by the summation of b sub n, and the only restriction is that for each n, an and bn must be positive. And then if the limit as n goes to infinity of an over bn is equal to L, and L is positive and finite, then both series either converge or both series diverge. In other words, either summation a sub n and the series summation b sub n converge, or the summation a sub n and the summation b sub n diverge. We cannot have one of them converging while the other diverges. So we get back to our series. The series that we're working with is the summation from 1 to infinity of the square root of 4n cubed plus 9n squared plus 1 divided by n to the fifth plus 16n squared plus 4. And as always, we call this unknown series our a sub n series. Now we have to carefully select b sub n series so that, one, it has to be a known series. We have to easily determine if it converges or diverges, and two, the limit as n goes to infinity of an over bn must be finite and positive. So let's look at this nth term of the an series. That's the summation of n equals 1 to infinity of square root of 4n cubed plus 9n squared plus 1 over n to the fifth plus 16n squared plus 4. So this is 4n cubed plus 9n squared plus 1 over n to the fifth plus 16n squared plus 4. Now let's remove for a second, let's remove the square root and look at what's inside it. 4n cubed plus 9n squared plus 1 divided by n to the fifth plus 16n squared plus 4. Let d be the highest power of n in the denominator, that's 5, and let capital N be the highest power of n in the numerator, and that's the 3 right there. So d is equal to 5, n is equal to 3. We subtract n from d to get 2, which is a difference in the highest powers of n, denominator minus numerator. This is how we select our bn series. So our series bn, n equals 1 to infinity, should be the simplest series, so that the difference in the highest power of n, denominator minus numerator, is 2. Of course, that's the series 1 over n squared, but then of course we had the square root, so we should put 1 over n squared inside the square root, and we simplify this. This is equal to the summation of n equals 1 to infinity 1 over n. This is our bn series. Of course, it is a familiar harmonic series. And now let's use the limit comparison test to see if we can conclude that both series converge together or diverge together. Let's look at the limit as n goes to infinity of a sub n over b sub n, and that's equal to the limit as n goes to infinity. First, in the numerator we have the square root of 4n cubed plus 9n squared plus 1 divided by n to the fifth plus 16n squared plus 4, and in the denominator we have 1 over n, but I'll write it as 1 divided by square root of n squared. So now basic algebra says that we're going to multiply the numerator, because we have square roots all the way around. This numerator will be multiplied by n squared. Every term in that numerator will be multiplied by n squared, and thus our limit becomes limit as n goes to infinity. One big square root, 4n cubed times n squared is 4n to the fifth plus 9n to the 4 plus n squared divided by n to the fifth plus 16n squared plus 4. And we can write this as the square root of the limit as n goes to infinity of 4n to the fifth plus 9n to the fourth plus n squared divided by n to the fifth plus 16n squared plus 4. Well, since the numerator and denominator have the equivalent highest power of n, which is 5, the answer is going to be square root of 4 divided by 1, which is square root of 4, and that's 2. This is our L. It is clearly positive and finite. So now the conclusion is that the series we're looking at, the summation from 1 to infinity of the square root of 4n cubed plus 9n squared plus 1 divided by n to the fifth plus 16n squared plus 4, this series, and the series we were comparing it to, that is the Bn series, which is in its simplest form was just a harmonic series 1 over n, either converge or both diverge. Since the series n equals 1 to infinity 1 over n, that's the harmonic series, and we know that this series diverges, so does our series here. So this series also diverges, and we can state that it diverges by the use of the limit comparison test. For more videos, visit www.mathprepvideos.com.